This lesson is on replacement when we are using order of operations. When you use replacement in math is usually when you are using formulas that you will learn on throughout the years, and you are going to replace certain letters in those formulas with the numbers that go with it. So one of the simplest examples that I give in my class is when you are converting Fahrenheit to Celsius. The reason is because I live in Canada, and in Canada we use the Celsius unit of measuring temperature, whereas in other places like the United States, they use Fahrenheit. And so for me, I'm not quite adept to knowing what Fahrenheit is in terms of like cold, hot. So I always need to convert it. I always use this rule here, this formula here that I've given you. So the formula is that whatever you get in Fahrenheit, you're going to subtract it from 32, and then you're going to multiply it by 5/9. So one example was, what if you were given 68 degrees Fahrenheit and you wanted to convert it into Celsius? So what you do is you call replacement. You would replace this F in my original formula with the 68. When we replace things, and you'll understand why as we move on this lesson, when you replace things, it's really, really a good idea if you put brackets, kind of like what I did here, put brackets around what it is that you replaced. Especially when we're dealing with multiplication, but for now, for the sake of this example, you can just follow along. Now let's talk about the order of operations at this point, which I have helpfully put for you up here at the top. So for us, the first thing we're going to do is our brackets, and 68 minus 32 is just 36. And I'm going to keep that in brackets because we are dealing with multiplication. And when we multiply this to our fraction, which is not something that you really need to worry about right now as long as you just worry about multiplying, if I do 36 times 5/9, I get 20. So that means that if it's 68 degrees Fahrenheit, it actually means that it's 20 degrees Celsius, which helps me out because now I really know what the temperature is in my kind of language. So now that we've done this simple example, let's just start off with some slow rote examples. My first example here, and I'm going to write example 1, is very simple. If I give you something like 9x, and I tell you that x is equal to 7, how would you solve for this? Well, 9x here, just kind of side by side, I hope you know that this means that it's being multiplied. And because it's being multiplied, when I replace my x as 7, I'm going to put nice brackets around it so that I know for sure that it's being multiplied, and I just get that the answer is 63 when x is 7. So that was a pretty simple example. But what I'm going to do is I'm just going to move this, and I'm going to do a second example right on the same page. Example 2. And for this one, I'm going to give you a division, which is 5y to the power of 3 over, or not 5y, 15y to the power of 3 over 5y squared, when y is equal to 3. What you should do is you should always rewrite what it is that you had originally, and instead you're going to put brackets around what you've replaced. And now I'm going to do, in terms of my order, exponents first. So I'm going to have 15 times 27 over 5 times 9. Now notice how I opted to put the times symbol, but I could have definitely changed this, and instead of putting the times symbol, I could have just put them in brackets, and you would have understood. Now we're going to look from left to right here, and I see that from left to right, the first thing is multiplication. So I'm going to be left with 405 over 45, which in our case is 9. And that's the answer for this next example. What happens if I give you something a little bit more difficult?